Hi everyone, we are going to review the Chapter 1 study guide, and something I recommend you do when you are studying for a test is to do the problems in your notebook so that you can always have a clean copy of the study guide to practice with again. It's hard to do that. A lot of students will just write on it and say, "Miss, that's okay." And maybe it will be okay for you, but I strongly encourage you to do this because you're going to want to review this again. And if you just stare at the answers, that's probably not going to be a great way to test yourself because the answer is sitting right in front of you. So it's kind of hard for me too. I want to just write on it, and in some cases I might have to, but give it a try. Okay, so remember, if you want to build with tiles, there is a tool on the ebook, and you can build these rectangles with tiles. Also, this is really important, you have to show work on the test. A correct answer without work. Now, some people will say, "There's really no work to do for this, Miss." Okay, I give you that. There are a few problems on the test where you really don't have to show any work. But in general, if there's work to show and you didn't show it, you're going to get 0 credit. But if you have an incorrect answer, if you have the wrong answer, but your work is correct, you will get partial credit depending upon, how much of your work is correct. So be careful with that. Don't just turn in answers. Make sure you show, if there's work to be shown, show the work. Okay, write the area of the rectangle as a product and as a sum. So I went ahead and built these using the eTool because I'm not going to write on the study guide when I told you not to. So if you're looking at these tiles, remember you do have this posted all around the room. So the length and width for each tile are on this poster. And actually on the posters I've got the area of each tile. So I'm going to go ahead and write the area for each tile on here. The area of this tile, this unit tile, would be 1. The area of the X rectangle would be X because 1 times X is X. The area of the Y, this is the purple rectangle. The Y rectangle, 1 times Y is Y. This is the green tile, the green rectangle. That area would be X times Y. This area of this blue square would be X squared, and then the purple square is Y squared. And you can use tiles on the test. That's fine with me. You can use these posters. They will be around the room. I'm testing to see if you know how to write it as a sum and as a product, not whether or not you remember the length and the width. So that's going to be posted around the room. So let's look at this example here. We've got an X squared tile, so we know the length and the width would be X for each. So let's go ahead and put that on there. For the X tile, the short side is 1 and the long side is X, so this would be a length of 1, a length of 1, and a length of 1. Now I can do this side. I don't really have to. We're not doing perimeter, but we can do this. This side would be X. Each of these would be 1. And this would be X, and this would be 1. Now really we're just doing the sum and the product. So the sum is all of these tiles added up together. So I've got 1 X squared tile, and I have 4 X tiles, so X squared plus 4X, and then I've got 3 unit tiles, so plus 3. This may look familiar. I think it was an exit ticket for some people. Okay, and then we're going to say that that's the same as the product of the length. And remember, we're talking about the length and the width. The length of this side would be this length plus this length. So that would be X plus 1. The width would be this length plus these 3 lengths together. So this length or this width would be x plus 3. And that's it. There's your sum, there's your product. Hopefully this is getting used to this and feeling comfortable with it. If you are struggling with this contopic multiply binomials, it's not going to ask you to write it as a product, but you could definitely practice with that, or you could use the e-tool on the ebook. Let me write that down. You could use the e-tools. If you go to the ebook and look at e-tools at the bottom, click on tiles, you could build your own and then practice writing the areas of product and sum. Okay, or I can give you like extra ones to practice with too. Okay, let's do the second one. Same idea, writing it as a sum and as a product. So let's do the length for all of the sides. The length for the x squared tile, each of those is x. This would be x here, this would be 1, this would be x. Each of these would be 1. And the short side of that x tile is 1. So for the sum, I really don't need the length for the sum. The sum is just all the tiles that I see. So I see 2 x squared tiles. So I'm going to write 2 x squared. I see 5 x tiles, so plus 5x, and then I see 2 unit tiles, so plus 2. Okay, for the product, let's look at this length. So that would be the length of these tiles added up. So x plus x is 2x plus 1. Whoops. Okay, and then my width would be x plus 1 plus 1. And notice it doesn't matter if I do this side or this side. They're going to be the same. Doesn't matter if I do top or bottom. They're going to be the same. So x plus 2. Now, if you're still really struggling with the product part, I can put some extra problems to practice with on Google Classroom, because really Khan's not going to check your understanding for this. It's only going to check your understanding for the sum. And it doesn't have individual tiles either on Khan. So maybe consider coming to the Saturday session or coming in after school one day to just get a little extra support with that. Okay, looking at number 2. Okay, I drew this on a separate sheet of paper, and I recommend that you do this in your notebook so that you have the right answers to refer to, but you can go back and look at this and say, let's see if I can do it without looking at the video or looking at the answers. Okay, write an algebraic equation for each figure below to express the relationship area as a product equals area as a sum. So we're doing the same process. We're writing it as a sum and as a product. So this you can practice with on Khan for sure. So x times 2x is 2x squared. And if you're wondering, when I get to some of these other boxes, how I'm getting the area, I'll highlight it. I'm doing the length and the width. In this case, I'm doing 4 times 2x. Okay, here I'm doing 3 and x, so 3x. And then here I'm doing 3, this is 3, times 4, not 3 plus 4. We are multiplying. This is area. We're multiplying the length times the width, so 3 times 4 is 12. So the sum would be 2x squared plus 11x plus 12. Okay, that's my sum. My product is given to me. This is the product. 2x plus 3. And I actually just remembered I have a poster of this on, and it's not up right now, or I think it's kind of hidden. So I will remind you of that on the day of the test, and I will show you where that is. There's a poster kind of with the individual tiles. Okay, and then this length is x plus 4, or you could put 4 plus x, either way. There's your sum, there's your product. This represents the area of this rectangle, so does this. They are equivalent, and you are actually factoring a quadratic when you do this process. You just don't realize it. Okay, for this problem, part B, we've got to figure out the length and the width. So we know the length and the width for x squared is just x and x. So now I'm going to look at negative 3x. I know that I'm multiplying the length and the width to get that area. Well, if this is negative 3x, x must be this length, so this must be negative 3, because negative 3 times x is negative 3x. Okay, let's look at 8x, length, width. Oh, I can't do that yet, can I? Oh yeah, I can. I've got x right here, so x times what would give me 8x? 8. Okay, and then for this box, length, width, so negative 3 times positive 8 gives me negative 24, so we must have done that right. Okay, so my sum would be, I'm going to write it down here, x squared, positive 8, negative 3, that's going to be positive 5x, minus 24, that's my sum. Product, length, x minus 3, width, x plus 8. Okay. For number 3, it says a rectangular garden has a length that is modeled by the expression 2x minus 1 and a width of 3x plus 1. What is the area in square units of the garden? So I'm just going to do an area model. I'm drawing this on a separate sheet of paper. I'm not drawing it on the study guide. I recommend you do this. Okay, one of my either length or width, 2x minus 1. So let's put that right here. 2x minus 1. Width, 3x plus 1. I'm going to put the 3x here. You could put it up here, but pretty much all of the problems we've done have had the x squared in this bottom left corner, so I'm sticking with that. I don't want to throw you off, but you could put 3x here and 1 here. You could also have these switched around and still get the same answer. Okay, now let's just multiply length and width. 2x times 3x is 6x squared, negative 1 times 3x, negative 3x, 2x times 1, 2x, negative 1 times positive 1, negative 1. Our sum would be 6x squared, positive 2 and negative 3. Combine those, that's going to give me negative 1x. So I can just write negative x minus 1. Okay, product. I don't even know if I had to do this. It just said area of the garden, but let's see. Well, it's not going to be hard to do. We've got the length and the width, so 2x minus 1 and 3x plus 1. Actually, I think all you had to do is this. So that's the area. I know it says in square units, but it's not a number, it's an expression. Okay, for number 4, you actually have a assignment called Classify Shapes by Line and Angle Types that I think might help with this. It's not, actually, I assigned it just now and I realized I should have assigned it during the day, so you may be wondering, where did this come from? Shouldn't be too hard, and I think it will help you with this problem. So which of the following statements is true about this polygon? Some of you did this for an exit, and then some classes we did not get to this. Okay, so if you remember what all these markings mean, the parallel lines are indicated with the arrows. So when you see the matching arrows, like on your quadrilateral template, these indicate that the lines are parallel. So parallel lines. So it's got a pair of parallel lines here. So this says the polygon has two parallel sides. That's true. That is a true statement. We also have two sides that are congruent. So maybe let's just write arrows mean that the lines are parallel. Tick marks mean that the lines are congruent. And remember, congruent means equal. So the polygon has two congruent sides. That's a true statement. These two sides are congruent. And then we also have congruent angles. This would mean that these two angles are congruent. That's not one of our statements. These two angles are congruent to each other, but that's not one of our statements. This polygon is a quadrilateral. Quadrilateral means four sides, so that's a true statement. So let's put quadrilateral, four sides, and then just to review, equilateral, all sides equal. I emphasize this a lot, and there's a reason. There's a reason you need to know the difference between those two. And those posters that were there in the first week of school, they're still there. Okay, number 5. Based on this Venn diagram, how are the shapes sorted? So let's look at these circles. If I look at circle number 1, if I look at these shapes, I'm noticing they're all triangles, right? So maybe number 1 is triangles, maybe it's something else, but I'm noticing these are all triangles. And then number 2, if I look at number 2, I'm not really seeing anything that they have in common right now. I just see that they're all polygons. I've got some triangles, I've got some quadrilaterals, but I have a pentagon, and I have 3 quadrilaterals. Wait, 1, 2, 3 pentagon and 2 triangles. So there's something that these all have in common. Maybe if I look at these more closely, I'll figure out what the label is for this circle. Well, I'm noticing that this triangle, the markings aren't there on the study guide, but I think they're there on the test. It's very obvious. These 2 sides are equal in this triangle. And really, I should have the marking there for the study guide, and I don't. So go ahead and add this marking here, and then add markings here. These 2 sides are equal. So maybe this has something to do with having 2 sides equal. This rectangle, let's go ahead and add these markings. Add them directly on your study guide. I should have added them before I copied them. These 2 sides are equal. These 2 sides are equal. Now I'm not putting any markings about angles for a reason. These 2 sides are equal. These 2 sides are equal. This has all 5 sides equal. This has these 2 sides equal and these 2 sides equal. So some of you may have figured it out. It's not equilateral because these are not equilateral. The pentagon is, but the quadrilaterals and the triangles are not. So it's not equilateral. But I'm noticing that at least 2 sides are equal in each of these polygons. And the same is true for the triangles that are in the intersection. So I'm thinking that this has to be triangles, and then this is polygons with at least 2 sides that are equal. So number 1 is triangles. Number 2 is polygons with at least 2 sides equal. And then the intersection are triangles with at least 2 sides equal. So I promise the one on the test will not be so difficult that you can't figure it out, but it might take you a minute to make sense of it. So I would recommend maybe bring a highlighter. I've got some in the class, but not a whole lot. Highlight one circle and just say to yourself, forget about this. What do these have in common? Maybe make some notes. And then highlight the other circle. What do these have in common? And I couldn't figure it out just looking at this circle. I had to look at this intersection to figure it out. And that gave me the idea, wait, 2 sides equal, 2 sides equal. Do all of these have at least 2 sides equal? That helped me to figure this out. So take your time with these. Write as much as you can on the paper when you're taking the test. And that way, if it's wrong, I can at least see that you were trying and maybe give you some credit if your work is correct. 6, if you need extra practice with 6, you have equation practice with angles on con. That will help you with this. There were some of you doing this exact same problem. Now you'll have some extra ones there that are not like this one, but that doesn't hurt. That's only going to reinforce how you should set these up. So that's a good topic to practice with if I go through this and you're like, nope, I don't have this. Okay, so when you see intersecting lines, if the whole picture's not there, you can take a ruler. I gotta remind myself, rulers and that poster. You can take a ruler and you can turn this into 2 intersecting lines. And then hopefully remember that's 360. Okay, if that's 360, half of that would be 180. So I know that together these 2 angles sum to 180. So these are, the relationship is that they are supplementary angles because this is a straight angle or linear pair, or you could just write half circle. That's fine. Half a circle, 180 degrees. So I'm going to go ahead and combine like terms, 8x and 7x, 15x, positive 90, negative 30, positive 60, because I know that this plus this equals 180. So I kind of skipped writing it all out. You had this on the checkpoint, you've had it on con. If you know that these 2 together add up to something, you can go ahead and combine like terms right away. Okay, solve for x. Take away 60 from each side, and then divide by 15, and that would be 8. And I think that's all we have to do here. Just says calculate the value of x, that's it. If you put this and it's correct, but you make a mistake here, you're going to get most of the points because then I know you did the relationship. If you do this and it's wrong and you didn't show me that you knew the relationship, I can't give you as many points. So keep that in mind. Okay, 7. And remember, number 6, or if you were struggling with this, equation practice with angles. Make sure that you do that. Number 7 doesn't look like anything we've seen because they've cut off part of the picture. So I'm going to, and you can do this, make this look like something we've seen before. Extend all the lines. You've seen this, you saw it on con. Okay, we're looking at two parallel lines cut by a transversal. These two angles, I remembered to bring home my tracing paper. And you can use tracing paper on the test. I'm going to trace one of these angles. And I'm going to translate it, slide it up to this intersection. Hopefully you recognize that these are vertical angles. Do you recognize them? If you don't, there's Khan that will help you. There's an exercise, there's an assignment on vertical angles. It was probably the first one you did. Okay, so vertical angles. Now some of you may recognize that these are alternate interior angles, and they are. But if you put vertical angles, I'll give you credit because I know you did the sliding. That's fine. So they are congruent. They're the same. So my equation is going to be 4x minus 9 equals 3x plus 16. Solve for x. X is on both sides. Let's get rid of the smaller one. So x minus 9 equals 16. Add 9 to both sides. So x equals 25. And that one was Khan. If you need help with that, equation practice with angles is a great one to, even if you got 100% on it, you could practice some more. It's not going to hurt your score. Once you get 100%, that 100% stays there. It's not going to decrease. So maybe practice, do one more round. Okay, number 8. We've got intersecting lines. Hopefully you recognize these are vertical angles, and it's the same process as the one we just did. 9x minus 5 equals 8x plus 3. Let's solve for x. Get rid of the smaller one. Add 5 to both sides. All right. I'm not done because it's asking on this one for the measure. That italicized M means measure of angle A. Let me highlight this. ACG. So ACG is this angle right here. So I'm going to take 8 and substitute it in the place of x. So that's going to give me 9 times 8 minus 5. I'm taking 8 and I'm putting it in the place of x. 9 times 8 is 72, and 72 minus 5 is 67. Okay. Number 9. We have an isosceles triangle. In an isosceles triangle, we have 2 legs and we have a base. These are my base angles, and the base angles in an isosceles triangle are, do you remember? You can probably guess and get this right. They are congruent. Now this is a little bit harder than what we saw on the checkpoint, because the checkpoint, I think they gave you these 2 angles and we just set them equal to each other, but they're not being very nice on this one. We actually have to use triangle sum, which we're probably going to do super fast one day, but hopefully you had that at some point in middle school. Triangle sum, all the angles in a triangle add up to 180. So first, I know these are equal. I know that this is also 3x plus 20. And then I can't set these equal to each other. That's not going to do anything for me. I'm just going to wind up with 0 equals 0. So I've got to use all three angles, and I know that all three of these add up to 180. So 3x plus 20, I'm going to write it out, plus 3x plus 20, feel free to combine like terms and skip this step, plus 2x plus 20 equals 180. All the angles in a triangle sum to 180. Combine like terms. (8x plus 60 equals 180. Take away 60 from each side. Divide by 8. And I think that's all we have to do on that one. Calculate x. Okay, number 10. We have parallel lines here. So these lines are parallel. They are marked with 2 arrows, but these 2 lines here are not. So be careful. Let's put a circle here and a circle here, and I kind of gave you the answer there, but these 4 angles here would match with these 4 angles here. They would not match with these here. These 2 lines are not parallel. These are. So these angles are going to match, and so are these 4 angles here and these 4 angles here. So let's do some color here. These are going to be the same. I don't know if this is going to look different, but these are going to be the same. And we're solving for x. Actually, you really just need to be clear with which angles match up. So once you do that, you're going to see you could even cover up this side of the picture. These sets of angles are going to match. And if you did the tracing paper, okay, this angle here, x, let's shade it in. If I slide it up, it's right on top of 95. So that means that x must be 95. Now that's kind of a hard one to do in your notebook, but you could draw that with a ruler and test yourself on that. If these are challenging, equation practice with vertical angles for, oh wait, that's not the one I wanted to tell you. Equation practice with angles, that's another one that will be a good one to practice with if you're struggling with this. But tracing paper, highlighters, I'll have colored pencils. I always have enough colored pencils, but my highlighters tend to dry out. All of that goes a long way. Don't rush through this. Okay, last one is something that we haven't really focused on that they expect you to know at this point. So let's look at this. After college, you get a job with a starting salary of $43,500. Your first day on the job is January 1st, 2010. You have a cousin working at the same corporation, but he was hired 3 years before you. So he was hired in 2007. Let's just make a note of that. Your contract states that you're going to receive a pay raise each year of 8%. So we know this is going to be exponential if we're talking about a percentage increase. We've done these on homework. You may not be proficient with this. If you're not, there is a con assignment that I did not assign, exponential model word problems. Or you could just really study this particular problem. There's nothing wrong with that. Your contract states you're going to get a pay raise each year of 8%. Suppose your cousin confesses to you that he started at $40,000 and he's been guaranteed a 6% pay raise each year. Okay, so I want to go back to 2007. It says write a formula that you could use to determine your salary given any number of years and your cousin's salary given any number of years. make a table showing the salaries of both you and your cousin for the next 5 years. I could actually do another video showing you how to do this on the calculator, but for now I'm just going to show you how to do it in your notebook. So let's get rid of this. Okay, so your job starts at 43,500. We know this is going to be exponential. Y equals a b to the x. And we know that this is going to be your starting point. And we know that this is going to be your multiplier. So if you're starting at 43,500, then your starting point is, so y equals 43,500. Your pay increase is 8%. So remember, 8% means 8 out of 100, and if you do 8 divided, you get 0.08. So your multiplier is not 0.08, it's 1.08. And if you don't get that, if you don't get this problem, I think it was the very first, it was the very first homework assignment. So go back to the first video. For the first homework, I explain this in depth. I am not going to do this on this video because it's already 36 minutes. But if you don't get it, go back to the first homework video and go through the example. It was problem 1-103. Okay, so your equation, this is you, is 43,500 times 1.08 to the x. Your cousin started at 40,000. Okay, so your cousin has a starting value of 40,000, and he tells you, okay, he's getting a guaranteed 6% raise. So his equation is going to be times 1.06 to the x. And we want to know, those are the two equations. We're going to make a table for you and your cousin for the next 5 years. So you're going to have to use your calculator here. And I'm going to show you how to do this with the calculators that are in the room. So I'm actually going to stop the video here and add on another video showing you how to do this with the calculator. And then I'll come back. I'm going to show you what the calculator is going to give us. Okay, I'll put this on the screen just so that we don't have to do 3 videos. So when we put this in the calculator, if I put this in the calculator for one equation and this for the other equation, I'll show you how to get the table on the other video. This is me. I started at this salary and I went up each year by 8%. I'm not going to do this one by one. I'll just let the calculator do the work. My cousin started 3 years prior to me, started at 40,000. So he goes up by this amount per year. So if you look at that, you can see that the cousin is actually going to start making more money in 2014 and is going to surpass you, even though you started out with more money. So I'm going to leave that there. I'm going to quickly do another video with the calculator, and happy studying.